So this is today's problem number 1498, number of subsequences that satisfy the given sum condition. So we are given an array of integers and we have to return the number of non-empty subsequences of nums such that the sum of the minimum and maximum element on it is less than or equal to target. Okay, and the answer may be large, so return it mod 1e9 plus 7. Okay, so first off, let's make some key observations. So because we are supposed to find out the number of subsequences, and we do not have to actually find out the subsequences. So this means that if we can sort the array, then it will be pretty nice, and that does not change the number of subsequences that's present, right? Because we'll be choosing elements from the sorted array, and that should be corresponding to the thing, right? And also you can see in this example, there are like six subsequences here, and we can see that we are being allowed to repeat here. Okay, so because so let's just think about sorting for a second, and then let's just like dive into how the actual solution would work. So basically, because we have a target here, so what we can do is we can use the two-pointer approach and look at this array. This is already like sorted, right? So what you do is we start initialize left with 0 and with right with the maximum number that whose sum doesn't exceed this target value. Okay, so in this case that will be 9, right? So if we have left on 3 and right on 6, then then all the subsequences that can be present here, which means that we just need to like choose elements to be present in our subsequence. Okay, so if they are present here, then that would be a part of the solution. Okay, because here the maximum and minimum, they're clearly like the sum is less than 9, right? Less than or equal to 9. So all of the subsequence elements also, they will also have their maximum and minimum sum to be less than or equal to 9. Now also we need to make sure that because we are going to iterate over the array, and we are going to be like updating left like this, like so, like left will move from left to right, and right will, because the minimum is increasing, so the maximum must decrease to like account for the target. So right will move in this direction, right? Right will move from right to left. Okay, so basically, because we are going to be updating this left value, we need to make sure that whatever subsequences we are generating from each left and right pair, they do not get repeated. So let's just fix one element. Let's just tick that 3 will always be the minimum element of all the subsequences that we select from this left and right pair. So from 3, 5, 6, we will have 3, 3, 5, 3, 6, and 3, 5, 6. Okay, so all of these they are right here, and we will be using all of these subsequences such that 3 is present here. Then so like what we have done now is we have exhausted all subsequences that start with 3, and then we basically move on to the next one. So like left becomes 5, and now the right, you can see that it like goes below left. It has to go below left, right? So like 5 plus 5, that is 10, and that's not less than or equal to 9. So there are no possible combinations with 5. So that's what we are going to do. That's the brief overview. Now this is the mod function. You can check it out. It's a very basic mod function, and this one is the number of subsequences function, the main function. And first we sort it, because that's why we are able to use the two-pointer approach in the first place. And then we do this like if the nums I plus nums left is less than equal to target, we like initialize right with that and break it. Okay, so this is the loop that initializes right. Okay, and if right remains uninitialized, then we basically return 0, because there is no valid pair. Okay, so basically the sum the number of non-empty subsequences will be 0. Okay, so now what we are going to do is that we have to make sure that 3 is always the minimum element of any subsequences where left is the where left is 3, right? So what we are going to do is we are going to use right minus left minus 1 plus 1. Okay, so because we are going to always use this, and 2 to the power that value will be the number of subsequences that use 3 between left and right. Okay, so for example, if right is 6 and left is 3, then right minus left will be 2, right? Because 2 minus 0, and 2 to the power 2, that will be that will correspond to each of these four values. And so that's like that's how you like get the four values right here. So and that's what we exactly do here. So we keep on updating answer according to the to this value, and while left is less than n minus 1, so like the left does not exceed the array and the num's length, we keep on incrementing left, and while right is greater than equal to left, we keep on decrementing right. And so basically, and this function right here, that's basically the moving to the next right value. Okay, now if right is less than left at any point of time, that means that we cannot have any more suitable suitable subsequences, so we just return the answer at that point. And if right is greater than equal to left, then we just we can also like put this in here, but whatever. So like we update the answer value, and we keep on iterating, right? And that's what we do here, and we just return the answer. So yeah, that's the approach. Thank you.